Okay, we are going to go over this homework assignment right here, which is due, what's today? Wednesday? Yeah. So, yeah, I wish. So, today is Wednesday. That assignment is due. We're on page 98, 7 to 21 odd. So, you had to convert these degrees to radians. How do you do that?
Well, you simply multiply by
Pi over 180, and then just reduce that fraction, okay? So I'm just going to read off the answers real quick for these. Let me know if there's any that gave you trouble. 7 should be pi over 3. 9 is pi over 2. 11, 5 pi over 6. 13, negative 5 pi over 3. 15, 5 pi over 2. 17, 10 pi. 19, 0. And 21, negative 5 pi. Everybody okay there?
Couldn't 17 and 19 be the same thing?
17 and 19.
360.
Well,
You see where I'm coming from? Because it's like, the 17.
if I turn something 1800 degrees, though, I really am doing something, right? So I do turn it.
60 degrees.
The end position ends up being in the same spot, but I had to do something to make that happen. I don't do anything to make that happen, right? So in other words, like imagine if it was a wheel and I was turning it and I turn it 0 degrees, a dot doesn't move at all. But here, the dot did move all around a whole bunch, you know what I mean? So it did travel. So that would be the difference there. Okay, so that's 7 to 21. So you just multiply by pi over 180, reduce. Any problems there? Yes, and the other one is just a reciprocal. You're going to multiply by 180 over pi to convert from radians to degrees. So that was 29 to 43. These are all in radians. You need to convert into degree. Please take a minute and look at all your answers for 29 to 43 and make sure that they have a degree sign on them. Because if they don't, they're actually wrong.
Make sure.
Good. If your answer is in degrees, you have to have that degree symbol. So very quickly, the answers here. 29 should be 60 degrees. These are all degrees. 31 is 315. 33 is 330. 35 is negative 30. 37 is 126. 39 is negative 48. 41 is 153. And 43 is negative 900. Any problems there? No, we're all right? So far, so good? Okay, then we had 45 to 63. So this is the same idea, but some of them are weird, right? So 45 to 63. So 45 to 55, we're going degrees to radians, but some of them have decimals or something weird. So let me give you the answers, and then I'll do out any in this little group that you want. So 45 should have been 0.68. 47 is 0.742. 49 is 2.43. 51 is 1.122. 53 is 0.9847, and 55, negative 0.832391. So, which of these do you want to do? 55. Okay. So, let me just grab my scrap paper. So, 55 gives us an angle in degrees in decimal form. So my answer is going to be a decimal as well. 47.6925. And how do I go from degrees to radians? What's the... Yeah, I'm going to multiply by pi over 180. So, since I'm already in decimal land, I'm just going to continue in decimal land. So I'm going to grab a calculator, and I am going to do... Move that up here so it doesn't fall. So, on my calculator, I'm going to do... Let's clear out this old stuff, see if you can see it. Negative 47.6925 times. Now you always want to use the pi button, and you will always have one on a scientific or a graphing calculator. So just locate your pi button. So there it is, times pi divided by 180. Okay, so there's my decimal, but I have to worry about significant figures. So how many do I have in that original? 1, 2, 3, 4, 5, 6. Right, so my answer should have 6. So I'm going to go out 6 decimal places. 1, 2, 3, 4, 5, 6. So that 1 should be my last digit. Since that's a 1, it'll just round down. Ew. Careful. Does that make sense? Any others in this little section you want to do?
Yeah, let's do
53. Okay. Oh, good one. So this one is 56 degrees, 25 minutes. So, you know what? Actually, I don't know what the calculator does if you type it in degrees and minutes with the times 180 over pi. Let's find out what happens. If I do 56, let's see if I can get the screen up here. 56 degrees. If not, we'll just change it to decimal. I don't know how it's going to spit this out. So 56 degrees, 25 minutes. And you know what? I'm going to put it in parentheses just for good measure. And I want to multiply that by pi over 180. Okay, good. It converts it to a decimal for me right in there, so I don't even have to do it. So, thank you, Mr. Calculator. So, that's going to be 4 sig figs, right? So, 0.984, and then what's this going to be? No one knows? It's a mystery? That fourth digit, is it a 6 or a 7? 7! Because the number after it's a 5, so that will be a 7. All right. Good to know. By the way, if you couldn't do this, do you remember how to change that into a decimal? What do you do with the 25? Yeah, you divide it by 60. So I would have 56 point whatever 25 divided by 60 is. So I'd get that. So 56 point blah, 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 blah. All right. We're okay up through 55? Okay, so then 57. Now you're just going the other way, but these were decimals, and they want your answer in degrees minutes. So let's see how you did. 57 should have been 114 degrees 35 minutes. 59 is 99 degrees 42 minutes. 61, 19 degrees 35 minutes. And 63 is negative 287 degrees 6 minutes. Which of these gave you trouble? All right, 61. So here we're going from radians to degrees. So what's the rule? I take, to go from radians to degrees, I thought you were right before, 180 over pi. Right? Yeah, 180 over pi. Okay, so first I'm going to get my answer as a decimal, and then we'll just convert it back. So, there we go, 0.3417 times 180 divided by pi. So, I have this decimal, but I want it in degrees, minutes. I think they said just round to the nearest minute, right? Do you know how to have the calculator do that for you?
I do not.
So if I have a decimal, and you go back to that angle, see this one? Choice 4. It has a little arrow and it says DMS. That's going to take your answer and convert it into degrees, minutes, seconds. So let's choose choice 4. So it's taking my answer and it's going to make it into degrees, minutes, seconds. Hit enter. There it is. So if I want to round to the nearest minute, what's it going to be? 35, right? Be careful. I know some of you might be thinking, but that's a 4. Wouldn't you round down? But it's 40 seconds. And isn't 40 seconds more than half of a minute?
Mhm.
Yeah, so that actually means to round up to 35. Does that make sense, right? Even though that's a 4, that's weird to think about, but you want to think about that's 40 seconds out of a minute. That's more than half, so I should round up. Cool. All right. Any other questions up to 63? You got a quiz in 2 days, remember?
Today's sweet.
On 3-1 and 3-2. Okay. Tomorrow, Friday? I wish. It's only Wednesday, man. Okay.
Oh my god. 2 days.
Friday.
Oh.
Today we're doing 3-2. Tomorrow we'll review 3-1 and 3-2 because there's a lot in these. They're quite packed. Okay, we had 2 word problems to talk about. 89 at the bottom here says, I don't know if I can get this on the screen. Oh yes. I love clock questions.
I hate clock questions. They're my least favorite.
Oh, I love them.
I don't even know what to read about. Oh, that's, what's a clock? What is a clock?
I keep dropping hints to my husband that I want a grandfather clock. Well, I came out and told him.
What's a grandfather
I don't know.
Alex.
Alex.
They're those big ones that have the pendulum that swings and they chime.
Beauty and the Beast, that's singing clock.
I don't remember. I want one like Mrs. Weasley has, and it tells her where all the people are. But fortunately,
Those things are expensive, aren't they?
yeah.
Those
But
are
on
like
Facebook
antique.
Marketplace, you can get them.
Those are
You can get them pretty cheap. Depends how nice you want it. I just want one that chimes.
12 and it's like,
Yeah.
just like that.
Okay.
Just
89. Here we go. Rotating hour hand on a clock. Through how many radians does the hour hand on a clock rotate in A, 24 hours, and B, 4 hours? Okay, so 24 hours. We're talking about an hour hand. So, how many full revolutions does an hour hand make in 24 hours?
You guys.
Yes, right? Because let's imagine it's midnight. It starts at the 12. It's going to go all the way around to get to noon. So there's 1 revolution, and then 1 more whole revolution to get back to midnight. So in 24 hours, the hour hand has completed 2 full revolutions. Right? Right? You with me? Right? So, 2 full revolutions. How many degrees is that? 360 times 2, right? Because 1 revolution is 360. So 360 times 2 is 720. And can't I just change 720 into radians? Once I know the degrees, I know how to convert between the two. So, how do I convert from degrees to radians? Times it by pi over 180. Okay, and I believe 720 and 180 reduce, that just becomes a 4. So 4 pi radians. Does that make sense? So that's in 24 hours.
Days.
Now, part B, they want just 4 hours. Well, you could go through all this again, or you could just think 4 hours is what fraction of 24 hours? 1/6. So couldn't I just take 1/6 of that answer?
Yeah,
Yeah.
pretty much.
So what's 4 pi over 6 really?
Oh,
2 pi over 3.
Yeah. So your answer to part B should be 2 pi over 3. Does that make sense? Everybody's all right? I'll take that as a yes. Okay. 1 problem left. 90. Rotating minute hand on a clock. So same idea, but now we're talking about the minute hand. Through how many radians does the minute hand on a clock rotate in 12 hours? So, let's start with the minute hand. How long does it take for the minute hand to do 1 full revolution? Minute hand. Minute hand. Right, so every hour it does one full revolution,
So
right?
24 of them in a day.
Correct. In 12 hours. So A is asking us about 12 hours. So in 12 hours it does
12.
12 revolutions. How many degrees is 12 revolutions?
Pi over 180. You gotta multiply.
Well, I want to turn it into degrees first.
Oh,
I guess you don't have to.
180 over pi.
Never mind. I guess you don't have to go to degrees as long as you know how many radians are in one revolution.
Oh, no.
3,
It's
2 pi.
2
over-
pi.
Yeah.
2 pi. One revolution is 2 pi. So if I have 12 revolutions, I can just multiply by 2 pi and get 24 pi. So then part B is 3 hours.
Oh, yeah. 3 hours, so 3 revs times 2 pi.
Mm-hmm. So 6 pi, right?
6 pi.
That's it. Okay, any questions on the homework? We're all right? Okay.